Hello, maurieo. How to land survey. Types of traverse. Closed loop hanging with radiations, joins and inverses. Hello, welcome. Well, in this video I'm going to try and explain the basics of traversing in land surveying and the different types of traverse and associated items such as radiations, joins and inverses. Now I'm going to do that by trying to draw the picture as we go using AutoCAD. Now I understand that I could make it quicker, but I think by sort of understanding how it fits together that you'll give a better appreciation of what's going on. So let's start our survey. So first of all, to start our survey, we usually need 3 old marks. One, and then we'll copy that one, CP, enter. And we'll just have 3 old marks over here. So that's all very good. And then usually we measure a line between them. Well, we measure between the 3 old marks. So I'll draw that. This is a line, a dotted line here, which we call, I've given that the line name of traverse. And because that means it's been measured and observed. Okay, so typically there's our 3 old marks. And we might say set up on this one here, and we might set that bearing there. We know from our known information we might set that bearing and just turn this angle around here onto this bearing to check they agree with our old information or the information that's on the plans that we have, because we've got to start somewhere. Okay, and then we'll measure the distances and make sure they agree within certain tolerances, and that we're satisfied that these 3 old marks haven't moved since they were surveyed, and that they agree with the old plan, so we know where we are in the world. So then the next step is to put some traverse marks in. So I'm going to just use this double circle here, which is very small because I need to change the scale of it here in AutoCAD, and there you go. That's pretty good size there. So let's put a few of those marks in. These are our new traverse marks. We'll put a few of those in around the place like so, and then we will traverse between them, or we'll measure and observe. So we'll set up there, possibly backside the other old mark, measure forward like so, and like so, and like so. So let's just say we started here and we set, well, we could say maybe set that one as our origin of, or we set this one as the origin of bearings, and then we checked onto that. So then we would go to here, set this bearing, measure that, make sure it agrees, and then we would measure this through to here. Then we'd come here, set that as our back bearing, measure and observe through to here. Come here, set that as our back bearing, measure and observe through to here. Here, set that as our back bearing, measure and observe through to here, and then set here, measure, set that as our back bearing and check that it agrees with this bearing here. If it doesn't agree with this bearing here, that would tell us that we've got a misclose, and then depending on what the misclose is, we might adjust the misclose to each of these angles so that the interior angles of the shape of the closed traverse shape add to the correct value, which should be the number of sides. So we've got 1, 2, 3, 4, 5, 6 sides, the number of sides minus 2. 6 minus 2 is 4. Times 2 is 8 right angles, and 8 times 90 is 720. Okay, so that the sum of these interior angles should be 720 degrees, and if it's not, by using bearings and various methods, we make sure that it is, so that we close the bearings. And then we put the bearings and distances together, and we say maybe start with our origin of coordinates here. Let's say this point here is the origin of coordinates, and we take that coordinate, and then we work out the coordinates of all these right around here, and we should come back to where we started. And if we don't, that's our misclose, and coordinate misclose. So we make slight adjustments to each one so that it does close, so that when the point that we start on is the point that we finish. Every point can only have one coordinate, one unique coordinate in the whole world. So we have to make sure that it's the right coordinate, and we have little adjustments. Now this here is called what we call a closed traverse. So I'll just put some information up here. A closed traverse. Closed traverse. Now that's a bit, that's a bit I don't know what I did there. Closed traverse. Okay, so put that there. And that's a little bit small, so I'm going to make that a bit bigger. I'm just going to make that 4 millimeters high instead of 2. So there's a closed traverse. Now that's pretty strong because it checks onto itself. It's totally independent, generally pretty independent of itself. We may have some small differences with the old plans, but generally we agree. And then all of the error can be adjusted out and so on out of that, and it's a very strong, accurate methodology, very self-checking. Any errors are well known, and they're adjusted out reasonably well. So that's the closed traverse. So the next type of traverse we've got is we might want to break that traverse down, and we should always obviously be working what we call working from the whole to the part. So in a sense, this now becomes the whole. We accept all those values as old. So now we're going to have a look at a loop traverse. Now in a loop traverse, so we might say, for instance, come here. So let's just copy one of these here, and like so, and I'll just put that there, and I'm going to put that into my new layer here, which is going to be drawing 2. Okay, and that's coloured magenta. So we might now put in another traverse, which goes from this old traverse here over, goes from this, perhaps this mark here, over into here. So we'll put some lines in for that, just to show how that goes, like so. So it's sort of like that there, like that there, and comes into there, like that. So what might happen with this traverse, because we know it's a loop traverse, we might set up here, and we might observe, set this here as the back bearing, check the distance, make sure it's all good. Possibly we could even check onto there, and then we measure and observe to here, set up here, back sight there, measure and observe to there, set up here, back sight there, measure and observe to here, set up here, back sight here, measure and observe to here, set up here, backside here, measure and observe down to here. Now you can see that that's not a closed figure, but what we can do is we can check by going through from taking this bearing here, checking through to here, making sure we agree with this bearing here. Now if we don't, then what we do is we adjust out any error into these new, or the angles here, into these new angles, and we adjust that out. It's sort of as if we had all this other stuff around here, but we don't use that. We just do it on the bearings, and so that there is called a loop traverse, because it loops from sort of one to the other, you know, sort of from this sort of information to the other. So let's just copy this here down to here, and we'll put that into this drawing 2 layer, which will make it go magenta, and then we'll just change that to a loop traverse. Now, depending when it's done, I mean, if this sort of traverse is not as strong as the closed traverse, because if there's a little bit of error in the closed traverse when you're coming through the middle, that error still exists. It can't be eliminated by this traverse here, because it's all one way. There's no check per se on the traverse itself, on your work, particularly if this is old work, and particularly if this is information from one survey, and sometimes this here could be information from another surveyor or another company, that any error in this is obviously put into this traverse through here. So it's not, it's got a good check on it, but it's not, there's, you know, it's not as strong as having a loop of all your own work. So what I often used to do, well, if I had GPS available in this situation, I might say GPS this line from here through to here, and then that means that I could close my own work and just see where the error lies. But the loop channel is, the loop traverse as it stands, is not quite as accurate as the closed traverse, but pretty much as good as. And if it is your own work, if you did the original closed traverse and then did the loop traverse, and there's not too much time between them, you can be pretty confident in it. So that's the loop traverse. Now the next traverse we're going to have a look at is what we call the hanging traverse. Now the hanging traverse, okay, so I'm just going to maybe put some in here, CP enter, and I'll just put that out over there like that, and I'll put that into this third layer here, layer 3, which has the color red. Okay, so the hanging traverse, I might just copy, and we might just put a couple of marks in there for the hanging traverse. Just say, I don't know, it goes like that. So the hanging traverse has no real check on it, obviously. So the types of traversing that I'm talking about here would possibly, I'm talking about traverse done with a total station. Yeah, taking the GPS out. So there's your hanging traverse there. Oops, it's not, didn't want. So I'll just gone a bit funny. I've got lost me the plot here a bit. CP enter. So let's just put that. Let's just put that in there, and then then that gets changed to the drawing 3 layer, which makes it go red, and then we can, so that's what we call a hanging traverse. Hanging traverse. Now that's got no checks on it at all, because you just you might set up here, you know, prove an origin off these marks, remembering, and then come out here, observe, set up here, backside observe, and so you've got no independent check of where you are at all. It's just what you can see why it's called a hanging traverse, because it well, it just hangs out there. It just hangs off the side. It's got no checks. Although, of course, what you can do is obviously get the GPS out, as I did with the other one, and close it off onto one of these other marks, or 2 of these other marks, or whatever have you. So, you know, there are options around these days, but in some of the olden times it wasn't quite the case. So depending on the accuracy that you needed, obviously a hanging traverse might be okay. But so that's essentially the 3 types of traverse there: the closed, the loop, and the hanging. Now, so say this is obviously a little bit of thing there. I've got a bit on. Didn't seem to. Yeah. So let's say, for instance, now that we've got this is a traverse round a site, and we've got some site boundaries in there. So I'm going to just insert, and I'm going to use these squares here, like that. Now that one's very small. I'm going to put that on drawing 4, and obviously then we'll put the scale of it up to 1, so that it's easier to use. Okay, so these might be, I'm just going to say in this case here that they're fence posts around our site. So CP, and I'm just going to copy, I'm just going to put 1 at each one, like that. So we might have set up our traverse so that we can measure to these fence posts, okay, that form the boundary of our site. So what would happen there is that at each one of these control points here, we would measure out to that there, measure and observe from here with a setup with a out to here, and these are called radiations. Now these are or hanging lines. So they're a radiation or a hanging line. So there's no like check on them at all. We can't check the bearing or even the distances. So sometimes we have little methods. We might measure and observe these twice. We might measure the distance, say in meters, and then measure the distance in feet and inches, just to make sure it's the same. Or we might measure the distance with a different pole height, or a different, pole height, or on a different scale. So these here, we sometimes have to do independent checks on those. So these are, there's no checks on these, so these are got nothing much to check them at all. So there's very easy to make errors doing these, what we call the radiations out to various things. And again, the whole to the part comes into it. I mean, if you're thinking about a topo drawing, these you can see that we do a lot of radiations out to various points, and there's no there's no check on, there's no independent check. We can't close them against anything, so we're really just left with doing them, you know, just as we can do them twice, and we can have ways of checking the measurements and that twice. So these here are called a radiation or hanging line. Radiation or hanging line. Radiation. Am I coming out of my box there? But thinking outside the square. Radiation or hanging line, they're referred to as. And oh, that needs to go into the drawing 4. Okay, so radiation or hanging line, that's what those are. So sometimes we do them as we're traversing around. I don't know, it's a bit of a tricky one. And sometimes, of course, they're pegs, so we're putting them in after the event if they're there, or finding them if they are there. So I like to, I have, my experience has been is to get your control sorted, get your control, do that, relate to any old surveys, any old survey marks or things like that, and then you know, and then do your radiations and put your pegs and things in. I should mention that sometimes we might say, for instance, so we might just for instance, I'm just going to go here. We might have some old marks from other surveys that we can just tie onto, and they'll give us a bit of a check. We can check back onto those, but I think that's probably getting a bit more complex than we need. So at this stage, that's our radiations out to there, and you can see that obviously that there's no checking, not much checking can go on there at all. All right, so then the next thing that we're going to do is we're going to go and do the joins. Now the joins are just calculated, so we don't show them as measured and observed. Obviously they're I'm going to show them with a continuous line. They're calculated, so there's a number of ways of calculating them, so let's just put those in. I'll just put those in here like that there. Oh, I just wanted to maybe change the line weight of that to, I'll just change it to 0.4. Okay, line weight 0.4. Now they're the boundaries, and we've got that all up there. So we can just draw those in now, like so. Okay, so they would be, and they're calculated. Sometimes they're calculated, called inverses or joins. So, well, there's a number of ways of calculating them. One of them is that we can coordinate all our traverse points, and then we can coordinate the boundary points, and then we can work out the distances by using total coordinates, joins or inverses, or sometimes called missing lines. Okay, Oh, I quite often put that 3 in there. Inverses or and now they're going to be in this colour here, the blue colour. Inverses or I don't know whether that it won't. Perhaps if I just try. No, I'll just go. Let's put that. Oh, I was going to copy that. Oh, missing lines. So that's 3 again. Okay, so joins or inverses or missing lines, and they're solid lines. Perhaps I should just put calculated. Now, we can calculate them just using the vectors, so we can come down this vector, along this vector, and up to here, and then that'll enable us to do that. And a lot of surveyors have a little handheld calculator with them in the field, and they're continuously calculating vectors. Most of us these days, of course, have a data recorder, so we can do a lot of these calculations in the actual data recorder itself. So that's always a little bit better. And then the other way to do it, of course, is, oh, these should be, what's happened here? These should all be 4 millimeters high. Okay, oh, that's better. Missing lines calculated. Yeah. Okay. So, yeah, so they can be done from total coordinates as well, once you've coordinated all the points. So, there you go. That's a little bit of a heads up on traversing. Yeah, it's gone 27 minutes, so it's quite a lot. But hopefully you'll be able to see the different, get an appreciation of the different types of traversing and the accuracy involved in each one. Now you can see that if you, I'll just go back to the diagram. If you start there with the closed traverse, that's the most accurate. The loop traverse is sort of the next accurate. The hanging traverse, not quite so accurate. And the radiations or hanging lines, about the equivalent of the hanging traverse in there, same. The possibilities for error are a lot greater. So we can, we used to write on all our plans, hanging lines have been measured and observed twice. So that's sort of a way of independent checking them, which we can be quite careful about. And then don't forget that these days we can always flick around with the GPS and just do a few checks that way, which is also quite good. And then finally the joins or inverses. Now these are typically, say for instance they were a fence line. Well, obviously you can't set up and measure down a fence line because, you know, there's lots of obstacles in the way. So they're calculated. So any error that's in any of the underlying work tends to make its way into the calculation. So they're probably the least accurate and of the three. And this is possibly a demonstration at the lowest end of working from the whole to the part. And then of course you've got, you know, from your various points you might do your topo shots, which are less accurate again because they're not actually to a physical mark or anything really. They're just you know, little spot heights here and there. So they're the least accurate at all, but they would be classed as radiations, although we tend to call them topo shots or something like that. All right, whereas the other ones measured and observed vectors to a fixed point or a known point. So yeah, I think I can just leave that there, and I think the next follow up would be by way of questions and what have you in the comments below. So if you find something, you want to clarify something or have a question, yeah, let's see you in the comments below. Any suggestions for things that you might want to know about with regards to land surveying, well, in the comments below. If I've got time, I can answer them pretty smartly, but some of the trickier ones that require a fair amount of setup and things like that, not so much. But anyway, if you like what I do, hit the like button. If you want to see more of my videos, subscribe. If you want to see my video, what the next video I do is push the make the little bell appear, ring the bell, and yeah, otherwise, cheers, see you.